All right, today we are diving headfirst into what is basically a medical mystery story. It kicks off with a super common diagnosis, but then a single unexpected clue flips the whole thing on its head. This is the story of the anemia paradox. So, at the very heart of this case is a fundamental contradiction, a real head-scratcher that challenges one of the most basic assumptions we have about anemia. You know, if you ask pretty much anyone what anemia is, they'll probably tell you it's a lack of iron. Your body doesn't have enough, so you feel tired, you feel weak. Simple, right? I mean, it is the most common cause all over the world. But what if you had a patient with all the classic signs of anemia, yet their body was actually overloaded with iron? That single counterintuitive question is what starts our entire investigation. So a typical case starts just like this. A patient comes in, and they're complaining of just being completely wiped out. They look pale, all the classic signs are there. And pretty much any doctor is going to immediately think, okay, we gotta check their iron levels.
So, let's meet our patient. We're going to follow the evidence, step by step, just as a medical team would in the real world.
Okay, our case is centered on a 52-year-old man. Looking at his file, we see a history of diabetes that hasn't been well managed, and also a long history of alcohol use. His main problem, the reason he's here, he's exhausted all the time. The first step in any medical investigation like this is a standard blood test, the complete blood count, or CBC. You can think of it as the opening page of the patient's story, written in their own blood cells. Now here's where things get really interesting. Check out this comparison. On the left, you've got our patient's results. His hemoglobin is low, 7.5, which confirms, yep, he's anemic. And his MCV, which just measures the size of his red blood cells, is also low. This is something called microcytic anemia. Now look at the column right next to it. That's a classic textbook case of iron deficiency. The numbers, they're almost identical. So at this point, every single clue is pointing in one very specific direction. But this is the exact moment the story takes a sharp turn. The next set of test results, well, it's about to change absolutely everything. So, given those CBC results, the logical next move is to run an iron panel. Everybody on the team is expecting those numbers to be in the basement, but they weren't. First, the serum iron. Normal is usually below 180. His came back at 210, so it's not low, it's high. This is the very first clue that directly contradicts the main theory. Then comes ferritin, which is a measure of the body's stored iron. It was 770. That's more than double the upper limit of normal. The body isn't starving for iron, it's practically hoarding it. And the final piece of this puzzle, transferrin saturation. It shows how much iron is actively being moved around in the blood. Ideally, you want this number under 45%. His was 85%. At this point, the evidence is it's overwhelming. So let's just let that sink in for a second. We have a patient who is anemic, no doubt about it, but his body is drowning in iron. This is not iron deficiency anemia. This is something else entirely. We need to find a new suspect. So with iron deficiency completely off the table, the investigators had to dig a lot deeper, looking for more subtle clues that would finally lead them to the real culprit. Next, they actually looked at the blood itself under a microscope. And what they found was a mess. A mix of small and normal-sized red blood cells, cells with strange little dots inside, and even cells with tiny clumps of raw iron that you could see. This confirms the big picture. The body has plenty of iron, it just has absolutely no idea how to use it to make healthy red blood cells. These clues were strong, for sure. But to truly solve this case, they had to go to the source, the factory where blood cells are actually made, the bone marrow. And inside the bone marrow, they found the culprit, a ring sideroblast. So what is that? Well, it's an immature red blood cell where the mitochondria, the cell's power plants, have become so overloaded with iron that they form this toxic ring right around the nucleus. This is not normal at all. It's the telltale sign of this disease. And that finding, the presence of these ring sideroblasts, well, that's the smoking gun. It is the definitive proof that solves this whole mystery. With that key evidence secured, a final diagnosis could be made and a clear path forward for the patient could finally be laid out. The diagnosis is sideroblastic anemia. And in this case, it's an acquired form, which links directly back to that detail in his history, the long-term alcohol use. We know this is a cause because it basically poisons the mitochondria and completely disrupts how iron gets used. And once you have the right diagnosis, the treatment plan becomes crystal clear. First, remove the cause, in this case, alcohol. Then manage the severe anemia with transfusions if you need to. You use something called chelation therapy to literally remove the toxic excess iron from the body. And finally, of course, you monitor the patient very closely. So, what's the bigger picture here? What can we really learn from this fascinating medical detective story?
This case isn't just about some rare type of anemia. It is a perfect example of why a logical, step-by-step process is so incredibly critical in medicine. The team followed the evidence, they questioned their own assumptions when the data didn't fit, and they just systematically hunted for the truth. And that leaves us with a final thought, doesn't it? The doctors saw anemia, and they immediately thought lack of iron. But the evidence was screaming too much iron. They only solved the case when they were willing to embrace that contradiction. It just makes you wonder, how many other problems could we solve, in medicine or even in our own lives, if we're brave enough to question the obvious answer when the facts just don't add up?